Okay, class, I wanted to do another video that would actually give you some practical experience in dealing with numerical conversion. In this section in the module of week 6 that talks about number systems, I go over two methods by which we can convert values from one base to another. So I thought I would go over some problems with you to show you how the process is done. I've got a tablet that I'm going to be writing the problems out so you can see how the process goes step by step. And I have a number of problems, some that are traditional base, which is base 2, 8, 16, and 10. And then I've got a problem that at least one or two problems that actually have a non-traditional base. But the process works because the rules are the rules and they apply to any number base. So I thought we would start off by going from an arbitrary base to base 10. So what we're doing here is we're trying to convert a value in the base 8 number system and convert the value to decimal. That's what we're trying to do here. It says 6/8, base 8 to base 10. Okay, now notice that I said 6/8, base 8, or 6/8 octal, because you would have a tendency to think that you could actually do 68. 68 is typically terminology used when dealing with numbers in base 10. So there's not a 60 per se in base 8. So I just said 6/8, base 8 or 6/8 octal, which is the same thing. Okay, so following a set of rules related to dealing with conversion of numbers from one base to another. This is an arbitrary base. This is a non-decimal base to decimal. We're converting a non-decimal base, which is base 8, to decimal, which is base 10. So the first thing that we'll want to do is, if you paid attention to the steps, the individual steps that were outlined, there were 5 steps. The first step in the conversion process is to find out whether or not the value that needs to be converted is a valid value. So in this case, it looks like 6/8. So the question on the table before we go any further is 6/8 a valid octal number? And if you were looking at some of the information related to the values of numbers in specific number systems in the notes in module A, it specifically told you what values are allowed in each of the traditional number systems. And just for reference, the numbers that are available in a particular number system is really one less than the base itself. So for instance, if you were to have a base 10 number system, the highest number you have in base 10 is 9, 0 through 9. In base 2, it's 0 and 1. In base 16, it's 0 through 15, but there is no 15 in hex, but there is the letter F. So it's 0 through F. But the octal number system, which this particular conversion needs to be, is the value the original value is base 8, which is called an octal number. Now, take a look carefully at the values. 6/8, base 8. And one of the things that you'll notice is that there is no 8 in base 8. Therefore, since step 1 in the process of converting a value of an arbitrary base to decimal, step 1 says, always check to make sure that the value to be converted is a valid value. This is not a valid value. 68 is not valid. 6 is, but 8 is a violation. Therefore, this value cannot be converted. That's an easy one. So if you want to save yourself a lot of time and effort, make sure that you evaluate that original number for validity. If the values if the numbers that are part of the value are in violation of the number system values, then your process stops. So that's a really good technique that you could use, and one in which saves you a heck of a lot of time. Let's go to the next problem. And so in here, we're tasked with the responsibility of converting 5/2 base 8 or 5/2 octal to base 10. Now, step 1, again, is to check and make sure that the value is valid. 5 is a valid octal number. 2 is a valid octal number. So this number this value, this 52, does check as being a valid value. The number of the values that are valid in the base 8 number system are 0 through 7. Remember I had shared before and in the module notes that the valid values that you have for a number is always one less than the base. The base being 8, the number of values is 8 total values, but the values range from 0 to 7. So this is considered a valid value, and we have to go through the process of converting this from octal to base 10. So moving on to step number 2, it says place the number in a column format, just so that it would appear on a piece of paper from left to right. And one of the things that I did in the notes in Module A is I actually put the value in like a table so that I could build exactly what it is that I need to do, multiplying column weight by column value. Now I'm going to do it a little bit differently than I did in the notes, just adding one extra step. So hopefully this will make sense to you. So what I'm going to do is I'm going to build my column weight chart, only instead of making it 2 rows, I'm going to make 3 rows. So here's my first row, here's my second row, and I probably made this a little bit too wide, but it only is going to have 2 numbers. It's got a 5 and a 2. So according to step number 2, it specifically says to put the value in the column weight, in column format. So this is our 5, and this is our 2, which is exactly what the value is. And I'm going to put a little arrow here so you can see that. And it is base 8, which means that the individual values are related to the octal number system. So just like in the decimal number system, remember back in elementary school, you had worksheets, and in a decimal number system, the rightmost column was the ones, and then the next column to the left is the tens column, and then the hundreds column, and the thousands column. That's pretty much what we're going to do here. We're going to create a column weight chart, and since we're using octal, it's going to be 8 to the 0, and this is going to have a column weight of 8 to the 1. One of the biggest mistakes that people make when they put together a column weight chart is they do not start the column weight with the right value. It's always the base raised to the exponent power, and we start off with 8 to the 0. If we're using hexadecimal, it would be 16 to the 0. If it was base 2, it would be 2 to the 0, and then so on. So 8 to the 0 has a mathematical value of 1. Any value to the 0th power has a mathematical value of 1. 8 to the 1st power is 8. And we're basically done. So I'm going to put a little bit of a heavier line here, because what is above this heavier line is the column weights, and what's below the line is the actual value to be converted. It says starting with the rightmost position and moving to the left, assign the column weights, and this is exactly what we had just done. Step number 4 says expand the value to be converted into the mathematical calculation by taking the column weight and multiplying by the column value. So what we're going to do is we can start, since we're talking about the associative property of math, if we start with the 5 or we start with the 2, it doesn't really matter. It does say multiply the column weight by the column value. And so let's take a look here. I'm going to change the color to blue, and let's do that again. Multiply column weight by column value. So here we go. It's going to be 2 times 1 plus 5 times 8. So we're multiplying column weight by column value, column weight by column value. Add those two multiplications together. We have 2 plus 40. Combine them together, we have 42. So the conversion from 5 to base 8 is equal to 40 base 10. Now, traditionally, if you don't put the base, like I did as a subscript, the implication is that it's a decimal number. But I did add the 10 as a subscript, just to be clear that you know that we're converting 5 to base 8 and converted to base 10. It's, I'm sorry, not 40. You're probably there sitting there saying, what the heck did he do? It's actually 4, 2, base 10. Okay, that's our conversion. Let's move on to the next problem. In our next problem, we're actually going to convert a value of arbitrary base to base 10. The only difference that we're dealing with here is the fact that we're dealing with base 4. And all the notes that I've spoken about brought up the most common number systems associated with technology, specifically computers and computer technology. But it doesn't mean that it's the only numbers that are associated. Here we're dealing with the base 4 number. So the first step, again, is to find out, is this a valid base 4 number? So recall from the previous problem, is that what we do is we take a look at the base, which in this case is base 4. Let me go back to the color red. And if we took a look at our base, this means that the allowed values are 0 through 3. Since we're dealing with values 0 through 3, the value itself, 3, 3, base 4, is a valid value, which means we got to do the work. So the first step, let's build the column weight chart. We can make it a little bit smaller. And we're going to make it 3 rows, like we talked about before, and 2 columns. We'll put the original value in here, 3, 3. We're going to take that 33, or the 3, 3, I shouldn't say 33, and put it there. Since this is base 4, the column weights are successive powers of 4. So we have 4 to the 0, we have 4 to the 1. And then calculating that out, anything raised to the 0 power is 1, and then 4 raised to the first power is 4. The next column, if there had been 3 values, the next column to the left would have been 4 to the second power, which I hope you're saying is 16 and not 8. It's 4 raised to the second power. So what we're going to do now is we're going to do the mathematics. And what I'm going to do is start with our first column value by the column weight, and then add that to the multiplication of the column value by the column weight. Okay, so here we go. 3 times 1 plus 3 times 4. This is 3. This is 12 for a total of 15. So therefore, the conversion of 3, 3 base 4 is equal to 1, 5, or 15 base 10. That's our conversion. Okay? It's pretty straightforward. I mean, it's once you get into the hang of it, the critical piece is to make sure which direction you're going. Anytime you're going from an arbitrary base, when I say arbitrary, I mean anything other than 10, to the decimal number system, this is the format that you follow. But that isn't always the case, right? So let's go to the next problem, and let's see what we've got as far as our problem. In this particular case, we're doing the opposite. We're going from base 10 to base 16. Now, the number's a little bit larger, but we'll get through it because you're going to be dealing with these kind of things when you're dealing with the real world. So here we have a 162 base 10, and we're trying to convert that to hexadecimal. So in the notes, if you were following the notes, one of the things that we were doing is we're converting under the there's 2 methods that I gave you notes on to convert from base 10 to base, in this case, 16. But it's method number 2, which I think is going to be easier for you to process and understand. And that is the example of successive subtractions in terms of getting the right value. So this is going to be a little bit more complex, not hard, just a little bit different. Still using a column weight chart. Since we're dealing with base 10, technically step 0 should be check and make sure that the original value, in this case 162, is a valid decimal value. You've been using decimal for probably most of your life. It's pretty clear to see the 162 is a valid decimal number. And just to be mathematically sure, the base 10 number system, the valid values are 0 through 9. The 1, the 6, and the 2 are valid decimal values, so we can move forward. So we're determining the step 1, according to the instructions, determine the base of the desired conversion. And the base of the desired conversion is base 16, and you find that right here. So that's going to be hex. And the reason why they call it hexadecimal, decimal is 10, hex is 6. Together, you have base 16, 0 through F of valid values. So knowing that, what we're going to do is we have to create a column weight chart based on the base we're converting to. So if we're converting to base 16, I'm just going to put 3 rows again. But there's a little difference here than we did in the previous procedure. You don't write the value in the column in the chart directly, not yet. What you do is you need to set up the column weight chart. Okay, so you got to put the column weight within the chart. Now, since we're converting to base 16, we're going to have powers of 16. So 16 to the 0, 16 to the 1, 16 to the 2. Now, you'll understand why I'm doing it this way in a moment, but in the column weight chart, when you're converting from decimal to an arbitrary base, there's really no way to tell how big to make the chart. If you do this with enough practice, you can pretty much tell how far you have to go, but I promise you there's a way that we can get through this. I just put 3 columns just to put them in, but you'll see we're not going to really need that many. So let's calculate what the actual weights are mathematically. So anything raised to the 0 power is 1. 16 to the 1 is 16. And 16 to the 2 is 256, if you calculate it out mathematically. So notice that last row is empty, and that's what we're going to be creating. We're going to be creating the converted value by doing successive subtractions. And the successive subtractions requires you to write the original value out and subtract the highest column weight such that the result is not negative. We're trying to shoot for a result of 0. So let's start that process. 1, 6, 2. So we just basically took the original value and rewrote it. We're going to do successive subtractions of the highest column weight in the column weight chart such that the result of the subtraction does not result in a negative number. Okay, so how many 256s can you subtract from 162 and still get a positive or 0 result? Now, even if you were to subtract 1, your result would be already negative, right? So there's not going to be any. So even if you were to try to do it, if you found that if you were to subtract 1 of the 256s, your result would be negative 94. And that's a problem. Okay? I mentioned before, you have to make sure that you don't get a negative result. All right? So what we're going to do is I'm going to go ahead and erase that, because we don't want to do that. And what we're going to find is that there are no 256s. 1, 2, 3, 4, 5, 6 of them. None of them you can subtract from the 162 and still have a positive or 0 result. So in reality, what you do is I'm hoping you're beginning to see. You pick the highest column weight, you try to subtract it. If you notice that if you even subtracted just 1, you would get a negative result, there is no third value in the converted number. Okay? So let's take a look at the next column, 16. How many 16s can you subtract from 162 and still not get a negative number? Well, if you multiply 16 times 10, that'll give you 160, which it looks good, because if you subtract 160 from 162, you're just going to get the remainder of 2. If you were to multiply 16 times 11, that would give you 176. And if you subtract 176 from 162, you'd go into the negative. So we know you can't go that far. But there are 10. So I'm just going to put 10 in the corner here, and I'll explain why in a moment. But what I want to do is I want to multiply our 10 times the 16. And that gives us 160. And then you subtract. And what you get is a result of 2. Now, before we take care of that 2, we're ultimately trying to get to a result of 1. Let's talk about that value 10 for a moment. What I'm looking for in the column, in this space right here, I'm looking for a single value. 10 is 2 numbers, but the number 10 in the hexadecimal number system from the notes in Module 1 is actually the letter A. That's what 10 is in hexadecimal. So it's really in that column, it's the value A. I'm going to cross this off because it's really an A. So A times 16, which is really 10 times 16, is 162. We subtract and we get 2. I'm going to go ahead and change color and see what I can do with this. How many 1s can you take away from 2? I think if you look carefully, you can do 2. So 2 times 1 is 2. We're doing successive subtractions, and we have a result of 0, which is exactly what you're looking for. So the conversion from decimal 162 base 10 converted into hex is A2 in base 16. And that's our conversion. It's done. Okay. Now, sometimes what you'll see is this, but it's the same thing. All right. And I think we may have one more problem. Let's try to do this one. Only this one is going to base 7. Okay. So you'll notice that the 53 is a valid base 10 number, and we're converting to some number in base 7. So the process is exactly the same. Let's go back to red for consistency. We're going to create our column weight chart. I'll do the 3 columns again. We're not going to need it. You'll see why in a moment. So we're going to base 7, which means that we're going to have powers of 7 in these columns. So we have 7 to the 0, 7 to the 1, 7 to the 2. Mathematically, that is 1, 7, and 49. Now we start our process of successive subtraction. We put the value, the original value is here, and I'm going to go to blue. And the first thing that I want to do is find out how many 49s can I subtract from the 53. You'll notice, let me take a look at something for a moment. I mentioned before we may not need that extra column, but we do. What I'm going to do is I'm going to put an extra column at the end of the chart here so you can see what it is that I'm referring to. And that would be 7 to the 3rd power. And 7 to the 3rd power is 343. Okay, so we can start with that. And you'll see that if you look at the original value, which is 53, how many 343s can you pull from 53 and still get a negative, still not get a negative number? And the answer is you can't. Even one of them would cause the result to go negative. So this is not included. So we go to the next column, and that is how many 49s can you pull from 53? And it looks like we can pull 1. If we had 2, it would be 98. That would go negative. The result would go negative. But if I subtract 149, and what I get is a result of 4. Okay, so with that in mind, we would go to the next column. How many 7s can you pull from 4 and still not get a negative result? Well, you can't, because if you pulled even 1 7, you'd get a result of negative 3. That's a problem. So this is a 0. That means we can't pull any 7s. Well, how many 1s can you pull from 4? Well, you can pull 4. So I'm going to subtract 4, and I have a 0 result. So in this conversion, 53 base 10 is equal to 104 base 7. You can apply these rules to any number system, and what that will do is it'll provide the opportunity for you to be able to convert between bases. So whenever you need those values, and whether it be in a programming solution or in some sort of a technology solution, you'll have the opportunity in the rules with which you can do it.